Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good, so last session we investigated this crash and we have a basic understanding of what is going wrong, but we don't know yet how to fix this. Yeah. Okay, what can we do? We need to get a better understanding of this attack machine. Yeah. So this attack machine is being created on Xfer. Or on enter. Yeah. Has machine. Yeah. Okay. So it is creating on enter. We are not using Xfer, so it is going here. It creates it here. AI attack machine. Then there's an update where it's being used. Yeah. Okay. And then on exit, straight away it deletes it and gets rid of it. On exit, does it also mean that it will destroy this attack state straight away? StateMachine. Exit. I think one way to fix this would be if we had reference counted. If this thing was reference counted, then we could say that where's the I mean, in the earlier here AI attack state, it's this one. So we are in here. So I think that this one, this on exit, let me go here, watch this. So the pointer ends with 52C. Yeah. And if we go down here to, what was it? AI attack state. So this one, now we went further down the call stack. And there we, oh, this one is different. Maybe it is the attack state that from some other entity that crashes. Yeah. Current state. Yeah, it's not clear to me how to fix this yet. But it probably 0. Does this attack machine contain children or? Somehow I cannot visit this. I can, okay. Just took a while. State map. The mapping of IDs to states. Current state. So a state machine also contains another state. And that contains a state machine again. Okay, I'm not yet sure how exactly this works. Tech machine. I think we would need an shit. We would need to defer the destruction. That's the current way I see it. The way to do it would be with reference counted objects, right? So if we hold the reference to that thing higher up in the stack, then it wouldn't prematurely delete it when it's still needed higher up the stack. So maybe we should, maybe a fix here is to say the attack state machine, the state machine. State machines, you could make them maybe reference counted. Sucks. So whenever we run an update on a state machine, we could here increase the reference counter, right? It is possible that the state's update method may cause a state to be destroyed. Jesus Christ. Oh, man. My gosh. Oh my gosh. AI text state updates. What? Oh my gosh. This is really worrying. This comment is worrying. Oh my gosh. Oh my gosh. That, no. That is unacceptable. It means that this is not a static function. We are inside that. No, this is illegal. I mean, this is a manifestation of the problem that this is designed like this. Oh my gosh. Okay, so the state is, this is the state machine, or is it state? A state. So should the state machines and the state be reference counted, or just the state machine? Oof. Oh my gosh. Game reset cause the execution of runtime variables during cleanup. What? Game reset. This is worrying. Oh my gosh. Oh my gosh. Okay, so we have states and state machines. Right now, we don't have evidence that deletion of states causes issue. It's a state machine that causes the issue. But here, this refers to the state. And so that is worrying as well. Oh boy. That is pretty bad. Oof. text state. Update state machine. Updates. Yeah, the way I see it is that there should be reference counted. I think so, yeah. 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 Mm. Mm. It makes it more robust, potentially also for other problems, yeah. Hmm. 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 Yeah, I think we must defer the deletion. That's a must-have. If the states and state machines can delete itself in this chain of execution, there needs to be a safeguard for this. Yeah. Yeah. We need to prevent the deletion, and basically only after the last user is done, then it can be deleted. Yeah. So let me see, how many call sites are there? Is this update here? Is this the... it's unfortunate that this function is called update, makes it harder to search for it. Let me see. We can search for this one, current state. Does this call update more than once or just once? On enter, on exit, update. It just calls it once, right? On exit, does that do anything interesting? Allow current state to exit. I don't know if the problem also exists with other functions or if it's exclusive to the update. For now, I think we can assume that we only need to be concerned about the update, I think. Yeah. Probably. Yeah. On enter. Can we take a look at some on enters? Let's see, AI text state, on enter, machine owner, something here, tech parameters, should exit. I guess it's actually quite big. I guess we should check where the on exit is called. Yeah. Let me search for on exit. We just do a search over the whole code base and see where this guy is being called. Roundabouts. Yeah. Okay, so on exits can call other on exits. Look at that. Yeah. Is that a problem? I'm not sure. If on exit calls another on exit, maybe it's fine. Instance. Problem is also all these guys, we call delete instance on them. We would basically need to overload delete instance for a text state and add a reference counter to that. Yeah. Delete instance. There's a way. Yeah, delete instance. Yeah. So it's not clear to me if chaining on exit is a problem. Probably not if it only concerns members. Yeah, maybe take a look at a few more. Yeah. It looks okay, but yeah. So do we have a ref count class? Ref count class. Ref count class. We do have a ref count class that is called ref count class. Okay. Yeah. That is part of wwlib. Yeah. This one is also used, right? In game engine, right? No. Huh. It's only used in WW Vegas. Do we not use ref counting outside of WW Vegas? Or is there maybe another ref count? Let me search for add ref. Add ref. Ah, here we have. Okay, that doesn't help. Do we have? Let me search for add ref like that. Do we have another reference counter class? No. No. Yeah. So I think what we need to do is there's also a macro for ref counting, right? Add ref. Here, ref PTR set release. Ugh. It's not great, this class. Yeah. Ref PTR set. Extra class. Yeah, okay, so the ref counter stuff is only really used in WW Vegas. I wonder if there is a separate ref counter class in Game Engine. I don't know. Ref counts class. Okay, Game Engine devices, some users. Okay, anyway, let's just use ref count class, and why not? Okay, let's go back to our code stack. So we have the state machine, yeah, and we have class state. This one, right? Okay, so memory pool object, yeah, delete instance, yeah, and snapshot. Okay, so state machine. Let me go to state machine. Let me remove this one here. State machine is pretty much the same. Yeah, okay. Then let's add a public ref count class here. Oh, we cannot. Oh. Okay. Okay. Guess we have to include refcount.h. Let's see. Include refcount.h. Okay. State. And then we go to the other one. here, state, do the same here. Oh, we already, state is in StateMachine, okay. Then we do here public, ref count class, okay. Okay, then I think what we need to do is we need to add an overload Okay, for starters, let's put let me go to delete instance. Yeah, so that is this one here. So what we do, here at the bottom, we put inline void delete instance, and we put state. Let me say state, and then we put delete instance, and StateMachine. Oh man, it's quite dirty though, isn't it? And then basically you would say hold on. If, let me see, ref count class, is it ref count class? Is it calling delete this or not? It is calling delete this. Aha. Okay, so we need a function delete this. I see. So, so delete instance, then we need to say state release ref. Yeah. Release ref. And then this delete this function. Let me see that. A virtual function. Oh. Delete this. Delete this virtual. But this release ref, it's calling conscast. I see. Why is it conscasting though? That's weird. Why? Conscast, not static cast. I see. Okay, that makes sense. Yeah. I see. Okay, so we need to have a virtual delete this. I see. Okay. Okay. Yeah. It probably should be a protected one, right? Ref count class interface virtual void delete this. And there we call delete instance call memory pool objects delete instance this. Okay, and then we add the same to the other one, this one. Oh, it's pure virtual. Huh? Oh, state is pure virtual. Oof. Okay. Okay. Huh. Okay. We will see if this one is getting called then. I'm not sure about that. We will see. Okay, and so yeah, so delete instance basically is just synonymous for release ref. Okay, and then what we do in the update functions. So here, update state machine. Let me go to here. You update, okay. Get state machine. Get state machine. Okay. So then we do do we have a helper struct for add ref release? Add ref. I would like a helper struct that just like does RAII wrapper for our for that thing. Ref PTR, maybe that. Ref PTR. Yeah, ref count PTR. Yeah. 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 Why is it setting this 0? Ah, right. Yeah, that looks like a good way. And we can pass it this guy. RHS peak? What? Yeah, I think this is the one we need. Ref PTR. Okay. So here. So we say st-ret. We do a scope here, yeah. Then we do this ref ptr, AI state machine. Do we need to include ref ptr? Includes ref ptr.h. ptr get state machine. What is this returning? What is this taking? fptr is taking ptr. Why is it not accepting that? That should work, no? Maybe it's const? No, it's not const. Why is this complaining? I don't know why. Okay, but let's assume it would work, yeah. It doesn't, but let's assume it does, yeah. Okay, so basically here we now hold a reference, yeah. Let's see, do we need to have any other place? Here's another one. State machine, update state machine. AI state machine. Ah, I see. Yeah. Okay, here we have another one. So this is current state in the state machine. Current state. Yeah. Yeah. So here I would say we also got this. Now I'm curious though. Oof, we have a problem. Oof. Do we have a problem? No, it's fine. It's fine. So what we do here is the same story. Same story. Status. I say status and I write static. Status. That. Somehow I didn't write it correctly. And current state. AI state. Now what is it? Current state is what? State. State. There we go. Somehow it is complaining. Guess we also need to include ref ptr here. Yeah. Okay, but this makes sense so far. This one is the in StateMachine, update StateMachine, yeah, okay. And the other one was... this one, update StateMachine. Hold on, but this is an AI update interface. Oh, I'm not so sure if that's the right place. State. We need to have a reference somewhere on the StateMachine. Do we have a general place for the StateMachine? This guy. What we can do is... How about... Current state. Current state updates. StateMachine. So the problem is this update StateMachine is probably called in many different classes, right? So if we search for update StateMachine, there are probably a lot of call sites, right? Yeah, see. Not so many. Not so many. Okay, it's less than I thought. Oh, there's a lock unlock. What the hell is that? Huh. We don't want to switch out of guard. Okay, what is that? Guard machine. StateMachine. Okay, but that's probably something else, right? Get machine lock. Locked, true. Locked. Lock, unlock. If a machine is locked, it cannot be reset. Cannot be reset. Okay. Cannot be reset. But can it be deleted? Okay, but what we can do, we could lock the StateMachine here. So we can put this guy here, PTR this. I don't know why this is complaining here. The ref count PTR should accept that, no? Why is it complaining? Oh. So do we have to do it like this? Why is this complaining? Anyway, I think we need to have this here. Update state machine. Yeah. And then in this here, AI doc state, update, doc machine, update machine, update. AI doc state, update. This is a pure virtual, the update. Oh yeah, it is a pure virtual. Okay, okay. I see. Okay, then I think this is a correct position. Yeah. I mean, it's a bit dirty that we do it in here. It would be cleaner if we do it outside. But then we need to touch a lot of files. We need to put it to all these here. Yeah. Yeah. Could do. Is there any downside to doing it inside the function? It would be cleaner if the reference counting was outside, I would say. Yeah. But I guess for now, for just testing, so move this outside at core sites. Yeah, I think that would be better. Okay, but then this position here is correct. This one is a pure virtual, and this one is they only place at courses. Why is it complaining? I think we need to stop debugging. Yeah, let's stop debugging here so we can properly see what the errors are. No instance of constructor matches the argument list. State machine. Why is this not... why does he not accept this? What is the problem? Huh? It should go in here, no? I don't understand. Allow automatic ref count PTR construction. I don't understand. Ref count. Oh. Okay, so why is this compiled out then? Why is this compiled out? Create new. So it wants us to call these functions? Get new? Create get? What does that mean? What is the difference? New and get looks exactly the same. Peak. What? What does that do? I don't understand. What does that do? Huh? Reference handling. It's okay. And with one of these calls, it doesn't add ref, and with the other, not. I see. Because we already start with a ref count 1. Then we need to call create get. Create get. Let's see other users of this. No one is using it. Is no one using this thing? Okay. Create get. And no one is calling this? What about create new then? Should be used when wrapping a pointer that has just been created with new. So if it's using peak, then we need to call it with get, right? No, actually, that's not true. We need to call it with peak. Because we want to add ref. Yeah, so it needs to be peak. Create peak. Is that used? It's also never used. Static card. What the hell is that? What is that? Oh my gosh. Create peak. Oh my gosh. Oh my gosh. I think it should just allow this here. Why is this not allowed? Why is this? Automate construction from a raw pointer is enabled if allow is defined. This may be useful when migrating existing code to use, but it's completely safe since it is not possible to get or peaked. Create functions. My object get. My class get. Ah, we have to use assignment. Okay, so it wants us to assign it like this? Like this? Nah. What? Why does it claim that this would work? It doesn't work. Why does it claim it works? That doesn't work. Peak does not add a new reference to the object. Let's see. Scan auto scope. Global create functions. Okay. What does that refer to? Create new wrapper that has just been created. Get should be used when wrapping pointer that has been returned. Create peak should be used when wrapping a pointer that has been returned from a peak function. Yeah, I see. Okay, what they refer to here is like, yeah, how they interface with other Vega's code. Yeah, I see. That's what it was built for. Yeah, so we would have to use create peak. Yeah. Then let's try that. Create peak. But that's so complicated to write because now we also need to put this here. Can we do like this without a type? No. We have to then do this. Oh, that doesn't work either. Has no member. What? But it's here. Create peak. A friend class. A friend class should be accessed like so. Maybe we need to pass it like so. Man, how is this used? Jesus Christ. Create. Return new my class. I'm a bit confused by how this create function is meant to be used with this as a friend class. It's not every day that you see friend classes. Yeah. Okay, so what was the intent here? I don't know. Create peak. It says create peak is undefined. I'm really confused about how this thing is supposed to be created. It's also weird that it seems to be used nowhere. Hold on. Let me see if there's any instance of that thing. Any instance. Okay, there are users. Okay. No. There are no users of the RefPTR. We are the first. Okay, that's interesting. Okay, I mean, if there are 0 users, and let me define this guy here. Where do we put it? Let's put it up here. Define that. Okay, then now this should work. Yeah. Let's go here. So now we should be able to do this. Yeah. Okay. And then here, yeah, we can also do this now. Good. So this looks fine. And this one, I think this one should not be here. Yeah, this one. Get StateMachine, get StateMachine. Yeah. Yeah, so here this is a call site. Let's for now, let's put the old code. So it was this here, that right? Okay. So now this one is reference counted, and this one. And yeah, this might work. There could be a problem now with in StateMachine here at the bottom. It could be that this one is not called for these guys. I'm not sure, right? But it could also be that it is called, because I'm not sure what C++ will do here. Let me put here and include pragma optimize off. Yeah. Okay, let's compile this and run it. There's a chance that this fixes the problem if it compiles. I'm really surprised that this refcount class is never used. Seems that they maybe added this at the very end of development. Seems like it. Okay, we have a compile error. Let's see what it is. Oh, what the hell is that? Fail if what is fail if? Jesus Christ. Are we the first user of the ref PTR? It seems like it. So it doesn't even compile. Oh, that's fantastic. Fail if 0 is not dummy. Fail if. Maybe I just. I don't know what if. What is this fail if? What is this supposed to mean? Can we just make it an if? If 0 is not dummy, false. So if dummy is not 0, and then the other, if dummy is not 0, it returns true. I'm so confused. Okay, let's just change it to if. I'm not sure about this. I'm really not sure. If 0 is not dummy, return false. Okay, anyway, let's run this. Let's see what happens. Fail if. Good. Skirmish. Battle bus crash. Okay. So we put the guys inside. We have breakpoint set on delete instance, right? Yeah. So we hope that, oh, the breakpoint is not set. Oh, because it's inline. Oh, that's not good. Let me double check that we install. We do. How can we get this to compile in? Let's put it into the CPP. Let's put it here at the bottom, like that. There we go. Let's make a copy of these. Put them here. Comment this out. There we go. There we go. Good. And then here we have these implemented. Okay. Let's try that. And then we try to put a breakpoint here, and hopefully that will debug. Hold on. I think I know what the problem is. Yeah. I think I know the reason. In state here, we have the delete this function, right? We are not supposed to call this. We are supposed to call that. Yeah. And so that's a first. That's a second. There we go. And then let's take these guys and put them a bit further up. Let's put them up here. Here. Maybe. Maybe. Maybe here. No. Let's see if that works. Oh no, that's stupid. No. It needs to call, no. It needs to call memory pool object here. Yeah. Otherwise it's just like infinite loop. Yeah. A recursive, infinite recursion. Yeah. Okay. Let's see if we have breakpoints now. We don't. Shit. That's not good. That is a bit worrying, isn't it? Let me go. Shit. That's really bad. Ref PTR class. Was it called like that? Shit. Ref count PTR. Good. How can we get this guy to? Shit. It's a really bad sign when we don't get a breakpoint in there. It means that this code is not compiled in. That's not good. Why not? Why would this code not be compiled in? We do have. Can we say no inline? MSVC no inline. There should be a decal spec, right? Oh yeah. Decal spec no inline. Let's try that. Maybe. Let's see. Okay, it's still not. So it's not called. Why is it not called? I'm a bit surprised about that. I would have expected it maybe for this guy, but this guy, I did not expect that. Delete instance. Because we do call this, right? what happens if we remove this and we go here and we set it to delete? What happens then? We should get compiler errors, no? Let's see. Huh, we don't, why do we not get compiler errors? Okay, that is, huh. Okay, that is unexpected, I would say. Let me find the state machine here. Here, current states, like this guy. Let me see. Okay, it's not being deleted. What about this one here? New instance. New instance. I would like to find all places that delete these guys and understand why it's not calling that. Find. Do we have any arrays? Huh. Is this list never cleared? What the hell? I'm shocked. Ah, here, delete instance. Okay. So here we have a deleter. Good. So it is calling it on state pointer. Why would it not? I don't understand. I don't understand. Why is this working? Okay, that is a mystery to me. That is really strange. I would have imagined that it wants now to call this delete instance here. And since we set it to delete, it should complain about this. But it doesn't. Why not? Why is it not complaining? Let's put it to inline. Oh, that should make a difference. I don't understand what the problem is. It should call states. It's probably some super stupid reason. delete all states in the mapping. Are states only owned by state machines? If that is the case, if states are only owned by state's machine, then I think we wouldn't need to reference count states and only the state machine. Yeah, that could be. Okay, but that's beside the point. We can still revert stuff later. But let me check, like, who is, but here, what is this current state? That's probably just a pointer to this, right? This is just assigning, right? It's not allocating. It's probably just assigning. Yeah. Well, if let me see where the pointers live. Current state. Let's search for state. State map. State map, state, new state. Okay, yeah, if a state is owned by a state machine, then we would only need to reference count the state machine, I think. Yeah. And because the state map is bound to the lifetime of the state machine. It does not get cleared beforehand, right? So let me go through all. This one. Nope. Nope. Dereferencing null pointer. Well, hopefully not. Oh yeah. If state equals null. Yeah, it's a bit strange that null is being checked after accessing it here, right? That's stupid. Yeah. Let me take a note of that. Probably can track it. Okay, so mstate map. Yeah, so why are we not calling these guys? That's what I don't understand. I really don't understand. It worked for this one. I remember we tested this and it worked for that. Yeah. But it doesn't work with these. Why not? Man. That's some bullshit. It's probably a really stupid reason why. But I don't see it right now. I don't see it. I'm oblivious to the problem. The problem is if we don't call delete instance, we need to find all the places that want to call it and treat them all. I would have hoped we can just overload delete instance. So we hijack all the calls and treat them as release ref. And then it would be done. We wouldn't need to touch a lot of code. It would just be automatic. But now we have this trouble that it's not calling this, and I don't understand why. Why is this happening? Shit. Delete instance. Maybe because it's const? Nah. It's not const. No. Oh. No. That's correct. Man. If we try to delete, hold on. Let's go to the state machine. Let's go to state. State. Here, state map. Here, destructor. Delete instance. Right. Let's run this. Let's see what happens here. We just load any map. Here, the big one. Jesus. Okay, let's just attack here. There we go. Okay, there we go. Delete instance. Supply truck idle state is ending. It has 1 ref count. And so this one is calling this one magically. Why? Okay, I'm shocked now. I'm shocked. I'm absolutely shocked. Shit. Why? Okay, that's not good. That is not good at all. Delete instance. Delete instance. Can we somehow can we I really don't understand why it is calling that. It makes no sense because in the state map it is a state. So why is it not calling the other? Let's be specific. Static cast, state, pointer. Yeah. I mean, it can't be more explicit than that. Yeah, let's stop debugging. But it still wants to call that function. I don't understand. Do we do anything stupid here? Delete instance. State. Class state. Class state. There's actually a override for functions that are not virtual. because you can also overload these. I really don't understand why it's not calling that. Oh. I see. I see. It's because I see. Okay, that took me long enough. It is a stupid reason. Now I know why. Because game memory The problem is that this one has the same name as this one. So if we call delete instance from within the object, then it will call this one and not this one. That's the problem. So we would have to rename this to like delete instance internal. Delete instance. Or yeah, delete instance internal, and then we call it here. Let me search how many callers are there for this. Just these. Is delete internal really a good name? Delete instance. I don't like this name. Delete. Maybe we call it delete MPO. Delete. Delete instance. Delete instance. Maybe we just put in like an underscore at the beginning. Delete instance internal. Yeah, I guess we can keep it. Yeah. Okay, then now this should work. Because now we are calling this bullshit. Oh man, that was really a stupid problem. Yeah, and now we can call it like this, and now it will actually error because it won't because it's deleted, right? That function. Game memory null still has that. Let me turn And so we do here. Okay, and now we can comment out these guys, and we put these guys back, and now they should work. That should work now. Let me go here to here. This place. Let me get that back. Yeah. this crash. It's just temporary comment, will be removed later. Okay. Yeah, that was not on my radar. That it will call the class member function first before it looks into the global scope. Yeah, now it makes sense. Oh, Jesus Christ. Yeah. Okay, there's some error here. Let's take these guys and put them to the end. There we go. Put the breakpoints in here. Okay. Good. Do we have the breakpoints now? No, we still don't have them. Jesus Christ. Oh my gosh. Okay. Then let's get back to this. To this bullshit. Man, nothing works. Then we go down here. We could have also tried this. Yeah, let's do this. Let's see what happens. Please don't inline this shit. Man, how hard can it be? Let me check first. Yeah, we have a breakpoint here, but not here. Oof. Why not? Okay, let's see what happens. Okay, so does it call the correct function? It calls state. What? 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 What is going on here? Why is it calling state? It's a attack machine. It's a state machine. It's not a state. Why is it? What? This is just a debugger showing funny things. This assembly. Delete instance state. Okay, I have no idea why it enters this function and not the other one. Maybe it optimized it in a way that it uses the same function for the same thing for both variants, for both types. I mean, it calls release ref, so I guess that's good. Yeah, it's inline to release ref. Oh, it does call delete instance here. No. Oof. It does make a call here. Delete this. Uh-oh. Is that proper? Let's see. Delete instance. Where's this going? Oh, it's also going in here. Okay, so somehow the compiler uses the same function for both because they essentially do the same thing, I guess. Yeah, okay. Fair enough. Fair enough. Okay. Then let's see what happens. Okay, that works. Okay, so that no longer crashes. That's good. Now I think we can actually also remove the one for the state. I think that's not necessary. It's only the state machine that we need to guard. So what I will do is, where is it? Here. So it's only this one that is needed. So I think we can remove this guy. So what we do is we simply put that. Oh, but it says it is possible that the state's update method may cause the state to be destroyed. But that's not true. The state is not being destroyed. It's only the state machine. May cause the state machine to be destroyed. Yeah. Yeah. So I don't think I don't think that the states will be destroyed on their own. It looks like that the state map is only cleared if the state machine is cleared, deleted. So let me double check this. But there I don't see. There's no clear. There's just here. It's just on the destructor that it deletes the instances, and then that's it. That's done. But it's not doing anything else with it. Yeah. Actually, let's take a look here. Okay. No. I think that the comment is wrong. I believe the EA comment is wrong. And it should say it is possible that the state's update method may cause state machine. The state machine. Oh, hold on. Current state. Oof. Where's current state? Current state is clear. Locked. Machine is locked. Cannot be cleared. A potential logic flaw. Machine is locked. Cannot be cleared. If the machine is locked, it cannot be cleared. Yeah. Okay. So, state machine X. Delete instance. Copy. I really struggle to understand how it came to be that they put this comment there, because whoever wrote this code, he must have realized that, man, how do we get there? Jesus Christ. This one here. The guy who wrote the state machine, he must have realized if he deletes the state machine, then this is garbage. Right? Update can change current state. So save it for a moment. Man, this code is wild. So it saves the state here, but then if the current state is null, it exits. Otherwise, it continues. Jesus Christ. Okay. Okay. It is possible that the state's update method. It is possible that the state's update method destroys the state machine and its states. But hold on. It's possible that the state method destroys the state machine and its state. But that can't be. It not destroys, clears the state machine. Yeah. So the only legal action would be if it calls clear. Where's clear? Here, this one. Clear set machine to a known initialized state. Clear. Yeah. Okay, so it is possible that the state's update method clears the state machine. Clears the state machine. Yeah. I think that is a proper comment here. I mean, anything else, it makes no sense that the update method destroys this object that we are currently updating. That makes no sense. But it does make sense that it clears the current state. So state is null, okay, and then we're done. I guess. Why not? It's not, at least it's not like programmatically, it's not illegal to do that. Whether it's logical in the sense of like the gameplay, I'm not knowledgeable about this yet, but it seems okay. Seems okay. Yeah. Okay, so I think what we can do is we can remove this ref pointer here. So we return this to what it was before, like that. Status equals that. Call update. There we go. And my expectation is that this will run now as well. So the only thing, it will hold the ref counter here. Now it's probably fine for now that we do this in here. Holding the ref counter there. It probably would be cleaner to move it outside, but maybe we just leave it in there, and maybe that's good enough for starters, and it could be moved outside maybe in the future. I don't know. Yeah. Okay, so my expectation is that this runs now. This is without crashing. Now we still then need to test if like the behavior looks okay. Yeah, get some asserts, that's fine. Okay, so battle bus looks okay. Rangers look okay, they have half damage. Let's take these guys now and put them into this bus. And so now if we shoot, let's put these two guys in there as well. If we shoot now, they should die in the bus, right? Because 50% loss, 50% loss, they should have 0 health and die. Let's see if that works. Yeah, that worked. Very nice. Let's try this house here. Boom. Wow, I survived this. There's a burden. Put the burden in there. It's a nice test map. Oh, what was that? Oh. Okay, what is this? Oh, yeah, I thought it leads me to some treasure here. Oh, the map creator led a nice path here, but there's nothing. That's not rewarding. Should have put some nice crate here with 20 million bucks in there. Yeah. Okay, but the crash is fixed, and it makes sense. To me, the fix is proper. I don't see any misbehavior. It seems to work fine. Yeah. 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 Let's put one guy in the bus. Okay, cool. I'm happy we were able to fix this. Now let's clean up the change. It's interesting that we had to touch quite a few things here to make this work. Okay. Good. So we can revert this one. And we can we can revert this one. Yeah. So for the state, we don't need it, so we remove that. We don't need that. Yeah. Delete instance. Delete instance. instance. Update machine state. Yeah, let me add a description here. The super hackers at bugfix. Today is the 20th of May 2025, which is a great date. Yeah, there's a lot of 2s and 5s and 0s in there. Defer the deletion of this state machine. Defer the deletion of this state machine. Actually, we can move this. We can move this to here. State machine has no current state. So here there's state failure. Yeah, so let's move this guy down here. I think we only need it there. No. Okay. Defer the deletion of this state machine. Calling updates can eventually attempt to delete this state machine. For example, if something kills the owner of this state, if something kills the entity of this state machine as a result of the state machine updates of this state updates. Update can eventually calling updates can delete the state machine in special circumstances. For example, if something kills the entity of the state machine as a result of this state update. Maybe we put a link to this guy. See. Defer the deletion of this state machine. Calling update can delete the state machine in special circumstances. For example, if something kills the entity of the state machine as a result of this state update. Calling update. Calling update can delete the state machine in certain circumstances. For example, if something kills the entity of the state machine as a result of the state update. Okay, I think that explains it well enough. Okay. Ref count. I wonder if we should include ref count and the ref PTR in base type, or let me see, base type dot core. No. What about base type dot h? Base type. What about pre-RTS then? Pre-RTS. Icky. Game memory. Game common. Game memory. Game common. I guess it's fine if we just put it here for now, right? Ref count, ref PTR. Okay, here we can remove it, right? Wait, let me double check. Yeah, reset. Okay, this one we also reset. Okay, then we also reset this here. Yeah, then we reset this one as well. And should I delete this? Yeah. So I think we move this guy. State machine. Yeah. So we just move it here, inline, okay. Let me put a line here. Calls Maybe we add super hackers to do use ref count PTR. Was it ref count PTR? Ref count class. What is it called? Ref count PTR. Yeah. Can replace delete instance with ref count PTR later. To do replace delete instance with ref count PTR when so appropriate. I think it would be nicer to wrap it into ref count PTR everywhere. So that would be a refactor. The super hackers add info is overloading delete instance to misappropriate for release ref. So overloads delete instance to misappropriate for release ref to keep the state machine fix small. To do replace calls to delete instance with ref PTR t ref PTR state machine when so appropriate. What I would say, let's say misappropriates delete instance to call release res. Misappropriates delete instance to call release ref to keep the state machine fix small. Replace calls to delete instance with ref count PTR state machine when so appropriate. Yeah. Yeah, I think for now it's fine to keep the change small. Otherwise, we would have to like touch all the different places that call delete instance, which are probably quite a number. I mean, maybe we can take a look how many it would be. Let's see first if it still compiles actually after making a bunch of changes. If it touches like 20 files, then I think it's better to not touch them now. Just keep the fix to a minimum. Okay, let's do a void delete instance delete. Yeah, let's see how many files will complain. 20 errors. Yeah, it's a bunch of files, 20 places. Kind of matches what I said. Yeah. So basically, we would have to make this a reference counter. We can make a follow-up change for that. How about that? Right. Yeah. Can make a follow-up change. Yeah, it's not too much. Let's make a follow-up change after the fix. That should work. But I think for now, this is good enough. Is anything actually inheriting state machine? Let me see. Public state machine. Oh, there is. Yeah. Can we verify? Text state machine. Can we find this guy? Here. Let me put once more the let's put a breakpoint here and here and let's go to Jesus Christ. StateMachine.h. Oh, Jesus. StateMachine. There. Let's go to the bottom. I just want to verify that it really calls the right function. Good. We also need to we should make this a separate change, right? The game memory stuff. Yeah, it probably should be separate change. I think we should revert this. Can release, because now it does release. How about we call this PTR is a bit bad name. Let's call it ref this. Ref this. Okay. Okay, then we test it once more. Skirmish. And battle bus crash. All right. There we go. Okay, so delete instance. Let's go to disassembly. And I just want to check that it really is calling the correct thing. How do we see? On exit, delete instance. Oof. Delete instance internal. Oh. Uh-oh. Uh-oh. Okay, that's actually not what I expected. Ah, actually, huh? Shit. I'm not sure if this is inlined for ECX plus 4. My gosh. Let's do the decker spec. Decker spec. No inline. No inline. Yeah. Let's try this again. My gosh. Oh wow, what is that? Error. Oh Jesus Christ. Oh. Okay. Let's put it down here again. I just really want to make sure that I don't introduce new issues. So I rather test it 2, 3, 4, or 5 times to really make sure I don't screw this up. Yeah. Because I'm not 100% sure that like what the rule is regarding finding the correct overloads, right? Here in this case. Yeah. But it looks to be reasonable to me that it would call in here instead of the other one. Yeah. Delete instance, debug, disassembly. And now it is calling delete instance, and that is calling release ref. Thank you very much. Thank you very much. Very nice. Very nice. Very nice. Yeah, there we go. Okay, that works beautifully. Yeah. Fantastic. Fantastic. Okay, cool. Then let me go to StateMachine, clean up. StateMachine here, please. Thank you. Delete this guy. Put that here again. Go here. Boom. There we go. Done. Done. Okay. Compile. Boom. Okay. This looks good. Ref PTR. Ref count. Good. We need to split it into 2 changes. And we also need to replicate it to generals. Let me compile in generals. Okay. Then the first thing we do is we search for void delete instance, and we simply replicate. Hold on. Void delete instance match case. There we go. So we replicate this guy. Is internal really a good name? Yeah, it's probably good enough. Why don't we see game memory null here for generals? Generals MD. game memory null external. Okay, looks like we need to search here. Ah, why is it so slow? Oh man. Oh, the disk is running wild again. My gosh. How is this possible? What are these softwares doing that they take minutes to boot? That is outrageous how slow this is. VS Code is so bad. It's unbelievable. Oh my gosh. So, game memory null here. Hello? There we go. Good. 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 That looks fine. And we have that replicated. Now let's replicate the other bullshit. So these are the first ones that needs to be a separate change. And then let's do ref ptr.h. Ref ptr.h. Ah, it's the core lib. Okay. Well, that's helpful. StateMachine.h. I don't know why it went back. Line 240. Here. Ref count class. Oh, what happened here? I didn't mean to touch that line. Huh. Let's reset that. Load post process. Okay. Okay. Go to StateMachine. StateMachine. Take this guy, put that here. Then we go here. To that. Current states. There we go. And then okay. Good. Let's see. StateMachine. Ah, there's a difference. machine. Let's end the state machine. State machine. Oh. Do we want it to be like that? State machine, state machine. There we go. Yeah, okay. Cool. Then let's open a new branch. Refactor memory pool objects, delete instance. Gen ZH rename to delete instance internal. What we could also do, instead of doing that, where are we testing? No, I think that's for the best, yeah. Yeah, I think that's best. Good, and then we create another branch based on this one, and we say fix state machine crash. Gen ZH fix crash fix crash in state machine when a child state deletes the parent active state. It's not really parent, it's more like fix crash in state machine when a chained state updates fix crash in state machine when a chained state machine updates deleted the executor state machine. fix crash in StateMachine when a chain StateMachine update deletes. Fix crash in StateMachine when a chain StateMachine update deletes the executor StateMachine. Is that an accurate description? Probably. Maybe. Maybe not. Fix crash in StateMachine when a chain StateMachine update deletes the executor StateMachine. It makes sense. I hope it's good. Okay, cool. Then let me see if that compiles. And then we can open the pull requests. And then we're done. We can also delete this bunch here. There we go. I'm not sure if internal is a good name for this function, but I can't think of a better one. Internal. Delete instance. It's not really internal because it is public. Delete instance member. Delete instance. I can't think of a better name. Delete instance member internal. Delete instance. Delete. Delete. Delete MPO. Delete. can't think of a better name. I don't know. It's probably fine. Good. Good. Then replace tracking reference. Good. So per request. So this is a follow-up for this one. Follow-up for that. This change renames per instance to reason being when overloading the global delete instance, then a call to delete instance within a member function of the of a memory pool object descendant will call instead of delete instance, which is confusing and error prone. Function of a descendant of will call. Okay. This change renames delete instance to that. Reason being, when overloading the global delete install instance, then a call to delete instance within a member function of a descendant of memory pool object will call memory pool object delete instance instead of delete instance, which is confusing and error prone. Instead of delete instance. Labels refactor minor. parent class. Okay, that's change number 1. And then we go here next. Fix state machine crash. There we go. Push. Okay. And that one is fix after this. Merge after that. This change fixes to 12. Fixes that. This change fixes a crash in StateMachine that happens when a chained StateMachine updates destroys the executor StateMachine higher up in the core stack. Or it's a fix the crash in StateMachine. That's when I change the prior executor StateMachine. This issue happened with 2.12, where the ranger in the bus would kill the power plant, and then the power plant destroy weapon would kill the bus, which would then stop the StateMachine, which would then delete the StateMachine of the ranger. When the ranger's StateMachine in the bus, when the ranger then the power plant there is a case to make that maybe another way to fix this issue would be with this lock thingy. StateMachine lock, but I'm not sure. Lock, unlock the StateMachine. Is locked. do quick exits. Get out. Lock. Is locked. Not is locked. State machine of the range. So this issue is, what is it classified as? Critical. Okay. Labels, critical, bug, crash, generals, 0 hour. Yeah. Milestones, stability. Yeah. Fix crash in state machine when it change state machine, update, deletes the execute the state machine. Fix crash when it change. Okay, cool. Good. Then I think we're done here. Yeah. Good. Then, oh, there has been 3 hours. Jesus Christ. Felt like 2 hours. Oh, okay. Okay, we had been busy. Good. All right, yeah, but we got a good fix done, I would say. It took, now altogether, it took 4 hours 30 minutes to get that sorted. Yeah, was a more complicated issue. Yeah, to understand what the problem is, how to fix it properly. There was no other user of ref count class, PTR. So that was odd. Yeah. Okay, there was a problem with delete instance. Yeah, confusion. All right, I hope you enjoyed. I wish you a great day or night. Until next time, goodbye.